Hey everyone, welcome back to my channel. Today we're going to tackle the Jump Game 3 problem on LeetCode. This is a medium-level problem, and we're going to break it down step by step, so make sure you stick around until the end. We'll be exploring a depth-first search approach to solve this problem, and I'll explain everything in detail, so even if you're new to coding, you'll be able to follow along. So, the problem statement is pretty straightforward. We have an array of integers, and we're given a start index. We need to determine if we can reach an index with a value of 0, by jumping from the start index to either the index plus the value at the start index, or the index minus the value at the start index. We can only jump to indices that are within the array bounds, and we need to avoid visiting the same index multiple times. The core insight here is that we need to explore all possible paths from the given start index, checking if we can reach an index with a value of 0. Think of it like a maze, where we're starting from a specific point, and we need to find a path to the exit, which is the index with a value of 0. We can move in two directions, either forward or backward, by the value at the current index. We need to use a depth-first search approach to recursively explore these paths, and we also need to mark the visited indices to avoid infinite loops. Imagine you're playing a game where you're standing on a tile, and you can jump to another tile that's a certain number of steps away. You need to find a way to reach a specific tile, and you can only jump to tiles that are within a certain distance. That's basically what we're doing here, but instead of tiles, we're dealing with indices in an array. Now that we have an idea of what we need to do, let's walk through the approach. We start by checking if the current index is within the array bounds, and if its value is non-negative. If it's not, we immediately return false, because we can't jump to an index that's out of bounds or has a negative value. If the current index has a value of 0, we return true, because we've reached our goal. Then, we mark the current index as visited by setting its value to -1, so we don't visit it again. Finally, we recursively explore the paths by jumping to the index plus the value at the current index, or the index minus the value at the current index. Now, let's take a look at the C++ code. We start with a function called canReach, which takes a vector of integers and a start index as parameters. The first line checks if the start index is less than 0, or if it's greater than or equal to the size of the array, or if the value at the start index is -1. If any of these conditions are true, we return false. The next line checks if the value at the start index is 0, and if so, we return true. Then, we store the value at the start index in a temporary variable, and we set the value at the start index to -1, to mark it as visited. Finally, we recursively call the canReach function, with the start index plus the value at the start index, or the start index minus the value at the start index, and we return the result of either of these recursive calls. Let's go through the code line by line. The line if start 0 start equals ARR size, ARR, start, equals -1 return false, checks if the start index is within the array bounds, and if the value at the start index is non-negative. The line if ARR, start, equals 0 return true, checks if we've reached the goal index with a value of 0. The line int temp equals ARR, start, stores the value at the start index in a temporary variable. The line ARR, start, equals -1, marks the current index as visited by setting its value to -1. The line return canReach, ARR, start plus temp, canReach, ARR, start temp, recursively explores the paths by jumping to the index plus the value at the start index, or the index minus the value at the start index. The time complexity of this solution is O(n), where n is the size of the array, because we're potentially visiting each index in the array once. The space complexity is O(n) as well, because of the recursive call stack. And that's it, that's the solution to the Jump Game 3 problem on LeetCode. I hope you guys found this explanation helpful, and you now have a better understanding of how to approach this problem. If you have any questions, or you'd like to share your own approach, please leave a comment below. Don't forget to like the video, subscribe, and comment your approach below.